Good afternoon, everybody. How's everybody doing today? Good? Everybody enjoyed the keynote? Yes? Good, awesome. So thank you for joining us this afternoon. We are today going to talk about Docker container security, okay? So, brief introductions. My name is Yuvraj Mehta. I've been with Docker for a little over a year now. I'm part of the product management team at Docker, focused exclusively on security. So if you guys have questions, concerns about security at Docker, find me. I'll be walking around in the hallway tracks.
Hi, I'm Steve Richards. I'm a solutions architect based in the UK. If you've got any questions about our products, if you're a current customer, want to become a customer, come and find us afterwards at the hallway track.
So before we get started, I want to give a brief overview of what this session is going to be about. This session, we are going to go over some of the high-level areas that we focus on here at Docker regarding security. And then for each one of those areas, we're going to present some of the core features and capabilities that exist in our enterprise platform that will help you deploy applications securely. Okay? And after that, Steve is going to do a demo showcasing many of those capabilities that we will talk about.
Did you bring the grapes?
No, I did not.
Oh, okay.
No grapes here. All right.
We'll cross fingers.
There's no grapes, and we're going to do it live. So wish us luck. All right. So when we look at security, security here at Docker, we want to categorize it across four main areas. Right? When we talk to customers, they are trying to provide security around these four main verticals. The first one, and many of you are familiar with it, is the secure supply chain. Basically securing the application in the Docker image as it moves from the developer desktop across your CI/CD pipeline. Next one is runtime security. All right, so now you have your application, it's going through the CI/CD pipeline, and now it's time to deploy it in production. Once it's deployed in production, how do you secure it? As it's running, what kind of security capabilities and boundaries you want to put around it? Infrastructure security. How do you secure the underlying infrastructure as well from the application? One of the core values that Docker brings is portability. You can take that same Docker image across infrastructures, right? So you want to make sure that that particular image does not affect the underlying infrastructure. And lastly, compliance, right? Everybody, I'm sure, many of you over here are probably part of some financial services industry, governments, healthcare, but you have to meet some sort of compliance and regulatory requirements that come down from your CISO organization, from your SecOps teams. So we'll present, what are some of the capabilities that currently exist in the enterprise platform that will help you meet those compliance needs. So let's first touch base on the secure software supply chain, right? So this kind of presents a high-level walkthrough of what a supply chain would look like. The supply chain obviously begins with the developers, right? The developers are creating those Docker images. They're then pushing them up to some sort of container registry. With Docker Enterprise, you get Docker Trusted Registry, which comes with two really important security capabilities. The first one being scanning. So you can scan for vulnerabilities, and second one being signing, so you can sign the images. Now, why are those two capabilities important? The main reason why those two are really important from a security standpoint is you only want to run trusted images in your enterprise, right? You don't want to run images that you don't know about, that you have not created, that potentially somebody has put in some crypto mining modules in there, right? So first thing, scanning. So with Docker Enterprise and Docker Trusted Registry, with the scanning capabilities, we provide a detailed scan results layer by layer of the Docker image, and we present what the vulnerabilities are and their criticality as well. So you want to make sure that any Docker image is scanned and you know what vulnerabilities exist in that Docker image. So now you've scanned it, right? The next step is to sign it. Hey, so we provide a capability that's based off of the CNCF project Notary, where you can cryptographically sign a particular image. And that signing will basically enable you to ensure that only signed images within your enterprise get executed and deployed in production as well. Okay? So trusted images, run only trusted images, scan them and sign them. Signed by folks who you know, who you trust within your organizations. Once you've signed and you've scanned those images, okay, but now you want to scale out that CI/CD pipeline, that secure supply chain. So with that, you want some automations, right? You don't want to be setting the same security policies and postures anytime you want to deploy and build out your supply chain. So as part of automation, we provide webhook capabilities. So DTR comes with webhooks that you can trigger anytime a scan fails, any vulnerability is found. So you can also, if a scan is also successful, you can promote an image from one repository to another repository as well. And this is all automated. Next, as part of automation, and you're scaling out your CI/CD pipeline, is promotions, right? You want to, as you scale out your DTR deployments, you can have a hub and spoke model. So you can have a central DTR that only pushes down images to other worker DTRs as well, right? So we provide a very highly scalable and highly automated deployment mechanism to help meet the needs of your secure supply chain. So with that, next we'll touch on runtime security, right? So we've built the image, we've put it through our secure pipeline, we've scanned it, signed it, great, it's automated. Now comes the time that we want to deploy it in production. Okay, so deploying it in production is running in production. As it's running in production, what kind of security capabilities do you want? Well, first one, you want to know that you're running, good images, right? That you are, inadvertently not deploying images that have vulnerabilities in them, right? So starting with Docker Enterprise 2.1, we have now added a capability where you can see in running images whether any vulnerabilities exist. You can view the vulnerabilities. You can roll up views across services, across pods, across controllers. So it's a very rich feature. Benefits, after you know what the vulnerabilities are, you can create policies so that you can take action against them. Like you can stop the service, you can kill the particular container as well. I'm sure you saw this particular feature work really well at the keynote today as well. So this was one of the things. Next, so once you have you know what the vulnerabilities are for your running image, you also want to control that. Hey, I only want to run the trusted images. You've signed them. Now you want to put that down as a policy that any time that any image is deployed, it should have a cryptographic identity that you can run. So today, this capability exists in our orchestration platform, UCP, right? The Universal Control Plane, which allows you to deploy images either through Kubernetes or through Swarm, and you can control that only the signed images coming from DTR should be deployed. We have now extended that capability as well to the core Docker engine, the Docker Enterprise engine, where if you are just running the Docker Enterprise engine, you can store the cryptographic keys at the engine, and only the images that have been signed by those keys will execute. Right? So after those two, now we have deployed the images. Now we want to provide some infrastructure security. Right? We want to make sure that the underlying infrastructure on which the containers are running is secure. Right? You want to make sure that nobody who is not supposed to have access to it should not get access to it. Right? You don't want bad actors. So with that, very recently in Enterprise 2.1, we have introduced SAML support. So how many of you in your organizations are using some sort of IDP? Okta, ADFS, Ping, raise your hands. See, a good chunk, right? In today's day and age, IDPs using SAML is just the norm in organizations, right? So you can centrally control who should have access to which applications. So with Enterprise 2.1, we've added SAML version 2.0 support. You can now control your user's identity directly through an identity provider, your IT-approved identity provider. So now you know, using SAML, you can know who, sorry. I'm sorry? Coming, not yet. Sorry, the question was, do we have OAuth support? Can we leave questions in the end, please? Okay. No worries. So now you know, and you can control who has access to your container platform that's been deployed. But now we go further, right? Okay, so now you know who you can control who has access, authenticated access, but now you want to go further. It's like, okay, now I'm on the container platform. I only want to provide permissions that are really required and only needed for particular entities, right? You don't want to provide authorization to everybody. So with that, we have very fine-grained RBAC controls that work for both Swarm and for Kubernetes, and for Windows, and for Linux. So over here, as you can see, if you have a dev team that's creating containers for Windows, and you might have a Java team that's creating containers for Linux, you can control that those two teams have only access to different nodes, different clusters. And you can control that access directly through grants, which exist in our Universal Control Plane product. So now you know we've put the image through our secure pipeline. We are securing it at the runtime. We're also providing infrastructure security, controlling who has access to what. But now your compliance department is still coming and saying, hey, we need to meet some regulatory requirements. We need to meet some regulatory standards. So I want to talk to you a little bit about FIPS. So how many of you are familiar with FIPS? Have you heard of FIPS or have heard of FIPS? All right, cool. So for those who are not, FIPS is a standard that's been established by the US government. Right? It's a cryptographic standard. Its standard says that certain cryptographic libraries should be used in IT platforms and IT systems. It is a standard that is largely similarly adopted by European governments as well. So there's a very big overlap. And so very recently, the Docker Enterprise Engine achieved FIPS validation. Basically, the US government is now saying that, hey, the Docker Enterprise Engine is so secure that it is that even the US government is willing to deploy it in their organizations. And this is the Docker Enterprise Engine is now the first container runtime in the market that is FIPS validated as well. So if you have if you have compliance departments and regulatory needs, you can now go to your compliance department and say, hey, we have a container runtime that is FIPS validated that uses a highly approved cryptographic libraries, and you can rest assured that you can deploy it in production. But even after that, right, just deploying an engine in production is not enough, right? As you've deployed it, day two operations come in, and you want to also provide detailed inventory back to your compliance department, back to your security departments of who has done what on the container platform. So with Docker Enterprise 2.1, we've now added capabilities to have really detailed audit logs that show you which user has taken which action, which API calls have been made, what the responses have been made, and we provide these detailed audit logs for both Kubernetes and for Docker Swarm as well. And you can extract these audit logs and you can integrate it with your existing SIEM solutions as well, so that you have a full dashboard that shows you across your container platform which users have taken which actions. Okay, now we're going to do a slight demo of some of the capabilities that we've talked about right now. So I'll hand it over to Steve.
Okay, so what we're going to look at is primarily focused on the secure supply chain in the demo. We're going to use a Jenkins environment to build a simple Java application, build a Docker image, push that into Docker Trusted Registry, and then we're going to go through some of the features that Yuvraj mentioned, the promotion policies, the vulnerability scan, etc. We'll then have a look in the universal control plane, show you how you can set up SAML. We won't do that today as we don't have a demo SAML environment, but we'll show you where you can go. We'll have a look at the audit logs, and then, hopefully it'll all go okay. Yeah. So we will start our Jenkins pipeline. It's going to take a couple of minutes to run. What I'll do is I'll just explain what this pipeline is going to do. So we're going to check out our code to begin with. Once we've got that code checked out, we're going to do a very simple build. This pipeline is running a Kubernetes pod. So we've got a Maven container, and we've got an Alpine container that's got some command line clients. We'll build the Java jar file. We will then package that into our Docker image. Within the pipeline, we're actually using build arguments and labels inside the Docker file. So this all goes towards our secure supply chain, knowing where this image came from, why it was built, who built it. We're then going to do a quick test, which is a simple run of the image, and then we will push that image across into Docker Trusted Registry. So whilst that's running, we've got build number 43 there, so we'll make a note of that. Okay, so Docker Trusted Registry, what we've got to begin with is a few repos here, but the first one the image is going to go into is the one that's marked private. Now, the reason we want to do that is we've not scanned this image yet for vulnerabilities. So we don't want that image to be released across all the members who have access to Docker Trusted Registry. So we push it into there to begin with. We can enable security scanning in DTR. That can be enabled on scan on push or as a manual scan. In this case, it will do scan on push. So as soon as we see our tag here, we should see that it's going to be scanning, and there we go. We've got it pending, and we can see that that is our build number 43 that came in. So we just go between the tabs here to see our scan results. Okay, so we've scanned this image now. We've picked up a certain number of vulnerabilities. In this case, we've got 13 major vulnerabilities and a hidden one, which I will explain in a second. So we can have a look at those, and as Yuvraj was saying, this is your opportunity now to go through these vulnerabilities, decide if you need to make changes to your Docker file, if you need to enhance your base image to get rid of some of these vulnerabilities, or if you want to do what I've done, which is actually hide a vulnerability because you're going to accept it in that image. So this view here, you can see on a per layer basis what components have vulnerabilities in them. And you can also go down to the component level as well and go through each vulnerability, see which layer has been affected. And you've also got a link here out to the MITRE website, so you can go through the CVE in more detail and decide what you want to do. So I actually hid a vulnerability, and the reason for doing that is I wanted to use a promotion policy. Now that promotion policy is going to enable me now to automatically promote this image into a different repository inside Docker Trusted Registry. Now my promotion policy is made up of a very simple criteria, which is no critical vulnerabilities, which is probably going to be pretty standard for most of the people here. But you can also add other criteria here like tag name, component names, major vulnerabilities, etc. And you can have more than one criteria. Over on the right-hand side, you can see where I'm going to push this image to. So it's going to go into my DevOps repository, which is actually publicly accessible through the organization. So now I'm happy with this image. I'm going to let people use it. The other thing I've set up in this private repository is a webhook. So this webhook is going to trigger on a promotion. When this webhook triggers, it's going to call back to my Jenkins, which will start a second Jenkins pipeline job to use the content trust. So that will do that separately and then push it back into Docker Trusted Registry. So if we have a look what's in our public, we can see here that tag 43 got promoted up, and we can see the second Jenkins job is actually run here, and we've got our image signed, pushed back into Docker Trusted Registry. So now you can take advantage of content trust in Universal Control Plane. So if we go and have a look at that now, so you can see what that looks like. Within UCP, you can enable content trust by going into your admin settings and going into the Docker Content Trust. From here, you can say that I only want to run signed images, and you can go one step further, which is say, I only want to run signed images that have been signed by particular members of a team. And that can be one signature or multiple signatures, as long as they comply with the teams that you've set here. So I'm not going to add any teams, but I will save this. Now, we're not going to run this image, but I will show you what will happen if we try to pull an image onto the platform that hasn't been signed. So I'm going to go back to DTR. I'm going to go to images. I'm going to try and pull the image that's not been signed. And we'll pick the one that we just built. Okay, and we can immediately see that this image has not been signed, is not going to be allowed onto the platform. So it won't even try pulling the image, it won't try and start containers, pods, anything. It won't allow this image onto the platform, is not met our content trust criteria.
Steve, I just want to mention one thing. This, as you can see, this you can apply this policy on our Universal Control Plane product, but we don't have the demo here. But if I think yesterday in one of the talks about the Docker engine, there was a demo, and we will post all these videos online, of course. You can see that the same capability now also exists on the core Docker Enterprise engine as well. So if you have use cases like Edge, or use cases where you have your own orchestration, you can still leverage the Docker Enterprise engine and still leverage this really powerful capability to control which images do run on the Docker engine.
Cool. So I've updated the tag here now to reference our signed one that we just pushed, and there we go. So just to show you that content trust fully working. So now that will have this image on the platform. You don't need to pull the images to begin with. Obviously, when you start up a container, if the image doesn't exist, it will pull it. And now that image is going to get pulled, and we can see it here. It's on the platform. Now, the other thing that Yuvraj mentioned was being able to see vulnerabilities now inside UCP. So we can see that over here. We're showing our one critical vulnerability, which I hid in Docker Trusted Registry to allow it to go through the promotion policy, but you will see that vulnerability here. This view, or the vulnerability view, as Yuvraj said, is available from this particular screen, from the container screen, pod screen, etc., etc. So we've got our image now inside UCP. So one of the other features we wanted to look at was how to enable SAML, if you're going to use that. So within admin settings again, if you go into authentication, you can see it's very simple. There's a SAML enabled box here. Tick on the yes, fill out all your details, hit save, and UCP will then connect to your SAML side of things, and that will all be set up. So very, very simple to configure. So
as part of SAML as well, we have single sign-on from UCP to DTR as well. So if you deploy both the Docker Trusted Registry and Universal Control Plane, you only need to enable SAML through the Universal Control Plane. You can do it either through API or through the UI, and that will provide similar single sign-on to DTR as well. So you can control who has access to your container registries and your universal control plane just through a single setting and through a single IDP as well.
And one of the last things we want to show is the compliance, the audit logs that are now accessible. So this is just a very small shell script. It's going to post a very, very small JSON payload to the universal control plane controller container, which handles whether auditing is going to be on or off. So you can see here, this is the request payload. We set the audit level tag to request. There's also another value metadata which you can put on. And then we're going to run a shell script here just to do some Kubernetes commands to get pods and services so we can generate some log messages. Here, this is the logs from our UCP controller container. And you can see here the more detailed audit logging that now comes out once we've enabled audit. We would expect most of you to be scraping these audit logs, taking them away into a central logging and monitoring system, and then being able to alert and interrogate them as needed. And that's it. That's a very quick run through.
Yep. Thank you, Steve. So next steps. Well, where should you go? Some of the next steps. First of all, get this Forrester report. Right? It goes into a lot of details about the various comparisons between all of the container platforms. Docker has been marked as a leader. Specifically, has been called out regarding the security capabilities and the focus that Docker platform has on security relative to many of our competitors. Check out migrating legacy Windows applications. We have a full-on services and tooling available for you to securely migrate your legacy Windows apps from Windows Server 2008, 2003 over to a container platform. And definitely check out trial.docker.com. Right? Give Docker Enterprise a spin. Play around with it. We have the Docker Content Trust capabilities, the scanning capabilities as part of this trial, and you'll also be able to be able to try out those same capabilities on the Universal Control Plane product as well. Cool. With that, thank you, and I'll open it up for questions. Yes. Sure, great question. So no, so the scanner that is integrated into Docker Trusted Registry is actually proprietary, is actually our own. There are open source scanners available as well. Some of them are Claire and Core, but we wanted to have a scanner that we can provide complete support end to end. So for now, it is a proprietary scanner. Any other? Sure.
I think I'm missing some point about the audit log part. I didn't understand exactly what the capability you're giving.
Sure. So for the audit logs, I wanted to reiterate what are the capabilities with the audit logs. So before Docker Enterprise 2.1, we didn't have the audit logs, or at least as detailed audit logs. So with Docker Enterprise 2.1, we took an initiative to make the audit logs that were available before to be even more detailed regarding also including API calls that get made, any kind of user actions. That happens as well, but we also wanted to make sure that those are available for both actions that are taken on a Kubernetes cluster or also on a Swarm cluster. Before that, it was largely only on a Swarm cluster.
And then I get like a webhook?
Yes, and you can scrape those logs. You can then integrate it and send them to your existing central security management system as well.
So works on managed systems like GKE, for example?
No, it will not be on GKE. This is integrated as part of the Universal Control Plane. No worries. Yes?
So two questions. First one, you're not signing the price in Docker.
No, we do sign. I'm sorry. Can you repeat the question?
Are you planning to introduce this functionality of signing the images or not?
Oh, so the functionality to sign the image of Docker Content Trust already actually exists in the Docker CLI. It is part of the Docker CLI already. So you can do.
Not part of this.
I'm sorry?
You use Jenkins to sign the images.
No, so this is the pipeline script that Jenkins was running. So you can see here, this is the stage where we sign the image, and we use the Docker trust command.
But you are using Jenkins to sign the image. It's not automatically done.
Oh, sorry. Okay. So yeah. So the trust command has to be done from a client terminal. So yeah. So we're just using Jenkins here to do that. But you can do that from your own client terminal if you yeah.
Are you planning to introduce the signing part into the?
Oh, into DTR. So as soon as you push, then get it to sign.
Great question. Not on our roadmap, but I would be willing to hear more details on what you're thinking. But not in the short term. But I think that's a good feedback that we can take back.
The second question is the signed image can be downloaded when you connect directly to the next. If I introduce a non-signed image in the YML file, would be downloaded?
No. If you've got content trust enabled in UCP, then every image that after that's enabled has to have content trust metadata on it.
Sorry. So the two questions were, as you saw, the signing capabilities, whether we have any plans on introducing the actual signing, the ability to sign the images into DTR. Not currently, but I think I'll sync up with this gentleman and we can talk more. And the second question was, I'm sorry, I forgot the second question.
If you can pull unsigned images from a YML file, manually apply.
Right. So if you pull unsigned images and you manually apply to the Kubernetes, will they run? If you have Docker Content Trust enabled in UCP, no, they will not run. If you have Docker Content Trust enabled in UCP, those images need to have Content Trust metadata in order to be executed. Cool. Yes.
So you can define policies of trust on the images, like how many major vulnerabilities. I'm thinking if you are operations team managing DTR, can you prevent developers from overseeing the registration?
Okay, so the question is that can we control developers to not go in and override any of the operations?
And oversees the,
Yes. So DTR also comes with RBAC capabilities, so you can actually control who has access to what and define what they can do as well.
okay,
Yeah,
but
so-
someone can see the repos.
Yes.
Not force push the image.
Yes.
With,
Yes.
Yes.
Yes. So they can see the repos, they can see what's in those repos, but they can't override the actual policies that have been set up by operations. Yes.
One question regarding getting this as SaaS. So do I have to host this DTR
So it is not available as a hosted SaaS service from Docker. This is something that just you would have to purchase. However, Docker provides tooling through Docker certified infrastructure that will allow you to deploy DTR and UCP into any of the public clouds, AWS and Azure, and also any kind of private cloud deployments like VMware as well. Yes. Do we have a company we're working with for? PCI compliant, that is one of the regulatory standards we are going to achieve early next year. We are in the process of going through PCI compliant. What was that the question? Okay. Yep. So one of the actual requirements for PCI is actually to have two-factor authentication capabilities available. So with SAML, you can go a long way because the IDPs already provide the two-factor authentication as well. So, but yes, next year, early next year, that's what we're going for in order to get PCI compliance as well. Yes. Yes, yes. Yes. So we actually have customers who need to meet PCI compliance who are already using the Docker platform, like Visa, like it was mentioned in the keynote yesterday. So Visa today, for all of Black Friday sales that happened on Visa, went through the Docker Enterprise platform. Okay. So, cool. Thank you, everybody. Thank you for spending the time with us. Hope this session was useful, and feel free to grab us at the hallway tracks or even now if you have any questions. Thank you.
Thank you.